Well, yeah, so we'll start at 10 past here in my office because I left left my house before I knew that the lab is canceled. They seem to have turned off the heating, so that's why the jacket. All right. All right. So I think we'll start. So the link on Piazza is to Zoom, which I think is more synchronous a little bit than the YouTube broadcast, which is might be slightly delayed by a few seconds. Okay. Good morning. In a way, I think what I had planned for today, which is just doing the pointer exercises anyways, might actually work better online. So maybe things are working out. So unlike in the physical lecture, I will not just like sit there and do the exercise and wait for you to do the exercises. I'll do them myself. That might be better in the sense of it's kind of quicker. It might be worse in the sense that you got to do the exercises at some point eventually, but like I don't feel like there's a point to me just like staring at the screen and you watching my face. So I'll just do the exercises. Okay, so we are here. And by the way, I threatened that there would be a quiz today, and there would have been, except that there's no, well, I mean, there wouldn't have been even if class had been canceled if there was snow. But there's going to be a quiz next time that we are on campus together, I guess. So, okay. So we are around here, and we were kind of around here. So I'll recreate arrays, stuff like that, and work with that. And then we'll continue on to slightly different structures as well. Yeah, feel free to kind of just unmute yourself, ask questions, or ask questions in the chat or anything like that. Please not in the chat on YouTube, which I am not checking. So, okay. All right, so we're doing type def struct student. And we're saying car name is something like this, and age is something like this. This is student. Again, this is the struct, and we're just saying that instead of saying struct student, we now say student. Student is a new type. So you can define a student like this. You can initialize a student like this. Okay, that's too mean. And you can also have an array of students. So an array of students in the same way that you can have an integer that's an integer array, rather, that's something like this. You can also say student s array 200. So this and this are the same. I'm just saying I have an array of students, and the way I indicate it is the type is student, and there is 200 of them. Make sense? So now let's say that we have a change name. So I'm just like repeating it from last time a little bit, and then we'll move forward. So if I want to change the name of a student, in the same way that I would have to send the address of the age, I have to send in the address of the student. So I'll send in the address of a student like this. And if I have an address, again, the easiest thing to do is to just get the name using ts arrow name, just because you know that this is of type student star. So the arrow just goes with student star. You can also think it through by saying something like star ps dot name. That's the same as s dot name. Okay. So in order to copy into the array, you have to use strcpy. If it were an array of integers rather than an array of cars, you would have to just like use a loop, or you would have to use a function that, so it's called like memcpy, which we have not done yet, in order to copy multiple elements at the same time. You cannot say the other thing, which we'll do in a second. So that's the legal one. You just cannot say PS name is equal to Michael, and that's just because you cannot assign to an array. Okay, and PS name is an array. Let me check the Discord. Okay, so there's a question about the lab 3 submission. Might as well answer it. It doesn't seem very quick. Should we submit 1C file? Okay, we won't be like very strict about it, but it's better if you submit one file just because it's like more convenient for us to grade. Okay, and again, like the grading is the same as in the in-person lab. If you made kind of reasonable effort toward completing a lab, you're fine. The way the labs work in 180, 190, as you know, is it's about making sure you're on track. It's not about assessing you, really, right? So just like don't make our life hard, and we won't make yours hard either. Okay. So, okay, all right. So that's like that. So that would be an error. Again, using this is the same thing. This works. So let's say that I want to set the name of S1 to Michael. I would send in the address of S1. That works, right? So that's because we're saying send the address of S1 to PS. So PS arrow is the same as S1 at that point. So in the same way that you could copy into the name over here, you can copy into the name over here. That works. So if you have an array of students, you can also say something like change name, address of S array 7. So the way this works, the principle is the same. We're saying address of S array of 7. S array of 7 is the name array. Sorry, it is the 7th student. And then we're saying send the address of the 7th student in the same way that you send the address of S1 to change name. Whatever change name did before, it's still doing. So that's fine. So there's multiple other ways of doing it. So you can say instead S array plus 7. And the reason it works, so we've done it several times already, is basically the address of cancels out with the asterisk in this way. So this and this are just the same. Okay. So that's another way of doing it. Right? Again, please stop me if there's any questions. So, okay. So now we'll create a malloc allocated block of memory that can store 5 students. And that would be like this. So again, it's exactly the same pattern as with integers. We're saying we need 5 students like this. Okay. So here we're saying make a function that takes in a pointer to an address of a student and sets the pointer to a new address where a student can be stored. So essentially this is saying make a function that takes in the address of this kind of guy and sets that to a new address. So again, like we've done it, but I feel like it bears repeating. So change int works like this. Right, so you're sending in the address of an integer and you're saying, go to the address, set it to something new. Here, we want to basically do something like this. So we'll name it like alloc student or something, or allocate. And that would take an address of this kind of thing. So that means that it's going to be an address of a student star variable. And we'll say set this to a new one. So the question said one student. So we'll do it like that. Technically, the function didn't ask for error checking. Like we had done with our manual allocate integer block, we can say if this turned out to be null, we'll say there was an error allocated in memory, and we'll exit. The reason those things are underlined is it did not include stdlib, so I'll include stdlib, and I'll include stdio, that's for printf. And I'll include string h. While we're at it, we used strcpy. So, okay. So that is now there. So now I can say, okay, I can call alloc student and give it the address of p block s. So the way it works is instead of setting p block s, a variable of type student star on line 41, I'm setting the address of p block s to here, and then I'm setting it to something new. So technically, like if you look at this code as it is, that would be a memory leak because I allocated this and then I never did anything with it, and then I changed it, so there's no way to free it. So I might decide to free it first. That's not part of the exercise. That's just like if this is a block of code, that is how it will work. Okay, there is a question here. Is a zip file acceptable? I mean, yes. What we'd rather do is for you to submit a single C file. Because I like yours spending time that doesn't really need to be spent. So like, please just make a text file, or like there's an option there to literally like copy and paste into that. That would be the easiest for us. Okay, there's no requirement that it's like a Git repository or anything like that. Yeah. Okay. All right. Are there questions about anything? Okay. So that's like that. So we call the function like this. So we now want to call the function to change the name of a student at the index 2. So here we allocated 5 students. And in the same way that I could call this here, I can call it here. That would be the same. So if you free the block, can you use it in the function? That's a good question. So what can and cannot you do? So if you're here, then after you freed it, you're not allowed to do something like this. This could potentially crash. You are, however, allowed to say, I want to change the value of pblockAs to something else. So you're not allowed to access or modify pblockAs at something. You're not allowed to go to that memory, but the variable itself is available. So the variable used to store the address of a valid block, then it became a block that's not valid. That's fine. You can set it to a new address. Make sense? Okay. All right. So now we want to create a variable that's the address of pblockAs. So this is similar. So this is a variable of type student star star. And it would be the address of pblockAs. So that's in a way the same, right? So here we had this kind of thing that was of type student star star because it was an address of student star. We could also explicitly make a variable like that. Fine. So without calling any function except strcpy using only pps, change the name of a student at index 2 to Jennifer. Right, let's say without calling any function. Okay. So how do we do that? So pps is address of pblockAs. So we want to get to the name of the second student, right? How do we get to the name of the second student? Well, one way is I just want to go back to pblockAs. To go back to pblockAs, I do star pps, right? So this is the same as pblockAs. We already know how to access this. So it's worth thinking about, okay, what is the type of this guy? So the type of this guy is address of student. So this is the second student in the block. So this is of type student. So to access the name of this, because it's of type student, it's not of type student star, we would say dot name. And now we do an strcpy, and this is Jennifer. There's multiple other ways of doing this, right? So I could also do pps plus 2. And if you're doing it as pps plus 2, then this is the address of the second student. It's not the second student itself. So then that means that this is an arrow, right? So if this is the start of the block, that's an address. And then this is the literal element in the block. So that means that this is a dot. This is a dot because this is of type student. But this is of type student star. Make sense? So that would be the same. All right. Let me check the Discord. Okay, that's Harry. It's not on Gradescope. It's on Quarkus. So I just decided, like, I'll set up the Gradescope as well, but I decided that because all the other labs are on Quarkus, it's more convenient for me that the submissions for the lab are also on Quarkus. Okay. Next one. So in the name of the second student in the block, change the first letter to J. Right? So, okay, how do we do that? So we have this guy. That is the array. So if that is the array, then this is the first element of the array. And now we can just say that is equal to J. Does that make sense? So, like, you got to think about it kind of step by step, where you just say, okay, like, if you know that this is the array, then you're kind of done. You're just saying, okay, like, this is the array. This is of type car star. I need to go there and change the first letter. That's just it. I think that's the most straightforward way to do it. So the question asks for kind of several ways of doing it. So a different way of doing it is, instead of saying at 0, you just star the whole thing. As you remember, those are literally the same, just because star A is, so star A plus 0 is star A is A at 0. Those are all the same, right? So the other two ways are just using this guy instead of this guy. So that makes it 4. All right. Okay. So we now are going to write a function that takes in a pointer to the first element of a block of addresses of student and changes the name of the student at index 2 to Jenny. So a pointer to the first element of a block of addresses of students. So that's different from what we had before. And if you look at, I think it's like question 4 from 2023 that had it. So let's read it carefully. So we're saying block of addresses, right? So it's not a block of students, it's a block of addresses. So let me change this to main 1. So it's a block of addresses of students. So what this means is every element is of type student star. So that means that this is student star star. Just name it B. So I'll first just define it. So what we have here is 100 addresses of students. So in order to store a student in this kind of thing, you first have to make b at 0 a valid address. So b at 0, you are now allowed to access it because b is a valid block. But this is not a valid address. This is just a random number right now, right? So in order to be able to operate on it, you have to first make it be a valid address. So one way to make it a valid address is to literally just say student test, and then say b at 0 is address of x. So now b at 0 is a valid address of a student, specifically this one. So now that b at 0 is a legal address, you can go and say b0.name, whatever, Jenny, like this. So this is now fine. It did not used to be fine without this. Or this is arrow. Right? So the reason this is arrow is b at 0 is an address of a student. And to access the name, we need arrow name. That's one way. Another way is to make b at 0 malloc allocate. And then again, you can just do this. Okay. So the idea here is initially what you have is a block that's a valid block, but b at 0 is not a valid address. It's just something random. So you can say b at 0 is the address of this specific local student test. Or you can say malloc, give me an address where I can store a student. And then once b at 0 is a valid address, you go and change the name to Jenny. So both of those are okay. Questions about this? So this is kind of complicated. Questions? Would the malloc? Yes, actually, thank you. This should be student star. Thank you. Yeah, that was wrong. Yeah, so what Javier pointed out is this was of type student star star, so this should also be student star star. All right. So, okay. All right. So now that we have this, so let's go back to what the question is actually asking. So we are writing a function that takes this thing that we just created, and it should change the name of the student at index 2 to Jenny. So that would take student star star B. And then it would go to B2 in this case, and change it to Jenny. So what the what the question asked us is to just make this function. So presumably B at 2 is a valid address. Make sense? So, okay. So one thing to note here is if we go back here, the type is the same. Sorry, I'll answer the question in a second. So the type is the same, but what this does is different, right? So PPS was also of type student star star, but it was a pointer to a block of students. So the type was the same, but here we have to say star PPS, we have to do star PPS at 2.name because the structure is different, because it's not. So because the array is of students, and then we just have a pointer to that. Here we have an array of addresses of students. Okay. Okay, so can we just say B student star star malloc size of student 100? Sorry, I'm reading the question. Isn't that what I said? Sorry, I don't quite understand the question because I believe that's kind of exactly what I wrote. Oh, can we not write? Oh, I see. I understand the question. Well, so the thing here is that this is the first time that the variable is declared. So you must declare the type of the variable on the left-hand side. So in the same way that you cannot just say a equals 10, you have to say int a equals 10. Here you have to declare the type of student star star. So what you can omit is this one, actually. So typecasting, it's kind of gonna let you compile it, but you have to declare the type here. So this is actually saying what type of variable B is. This is just typecasting the right-hand side. So this one is optional. This one is not. Of course, the second time, you can do it as many times as you like. So it would be nice to free B in the meantime. So the second time B is already declared, so it's fine. Make sense? Okay. Does it make sense to everyone that those two, even though the type of PPS and B is the same, that those two are different? Does it not make sense to anyone? Anyone in the chat wants more, like another explanation? All right. Okay. So create a pointer to a block of 10 pointers to students and store it. So we've already done that. Call the function to change the name. So here we created B. So this would just be B. So B is of type student star star. This is of type student star star. So you just call it with B. Write a function that takes in the first address of a student in the block of addresses of students and changes the name of the student, the first address of a student, and changes the name of the student at index 2 to Jenny. So this question I actually have to fix because it's written in a weird way. So the idea is you get, or at least kind of the way it's supposed to work. So you get the address at index 2. So to access the name, because this is of type student star, so this is an address of a student. you go to the name using the arrow and you get Jenny. So there is a subtle typo here, which is like, so it says, right, the function that takes in the first address of a student and the block of addresses of students and changes the name of student at index 2. You cannot actually get from the first address, if it's literally the first address rather than the address of the address, to the student at index 2. So to call this function, you just call it with the block of addresses. All right. Questions about the exercises? Okay, so I want to do one more thing here, which is to define a different struct. So far we did this. You could also define a struct like this. So what I've done here is, rather than have the struct have an array of size 1000, I made it so that the struct has a name. So, sorry, just a pointer to a car, so just a string rather than an array. So if I define a name like this, unlike before, I can say name used to be Mike and now it's Michael. That is fine, because what I'm doing is I'm saying name used to be the address of this M, and now name is going to be the address of this M. This is completely allowed. On the other hand, as you remember, this is not allowed. This is not allowed because this is implicitly saying like name at 0 is equal to capital B and so on. And you are not allowed to go and modify string literals. So technically, this would be a warning because the right-hand side here is of type const car. And if you do it like this, then this would crash. I mean, it could crash either way. All right. So in the same way that this is the issue with just car stars, this is an issue if it's wrapped inside the student struct. So if I say student1 S1, and then I say strcpy name, sorry, S1 name Bob like this, this is also not allowed in the same way. On the other hand, now saying s1.name equals Bob is fine. It's exactly the opposite of what would happen if this were an array. So an array, you can modify the contents, but you cannot reassign. A car star or a const car star, you can reassign, but you cannot write to the contents. Make sense? So now if you have a student 1 star, you can say, just like I said in the main function, PS1 name equals Bob. That is now fine. You do not have to do strcpy. In fact, you're not allowed to do strcpy. Another thing that's interesting is that before it was just not enough. So before, if you sent in an S1 like this, you could change it and it would be a local variable. In the same way, this is also fine, but doesn't have an effect. So Javier asks, can we use malloc on the car star? Yes, you can. Okay, and that is going to come up in the lab next week. Okay, I kind of feel like this was a lot, so it was enough. So I'm not going to do anything else today unless people have questions. Okay. All right. Well, enjoy the snow day. Uh, oh, okay. So there is a question. So why does the new function not have an effect? So that's just because you're copying S1 to, and you're copying S1 to a new to a new thing. So in the same way that if you say like change int wrong int a, and then you change like a to something else, that's fine, but it just changes the local S1. It doesn't change the global S1. So what is interesting, and I kind of already stopped, is that this, in the situation where it is allowed, does have an effect outside the function. And that's because here you're going to the address dot name and you're changing its contents. Right? So, but we kind of stopped that. So like we'll do it next time. Okay. So why is this of type student? Well, so this is star star. So this is type student star plus 2 still of type student star. So if something is of type student star, then arrow name cancels out another star. So this is type student star. So then to access the name, you do an arrow. All right. Cool. All right. Okay. All right. So I strongly suggest. I'll make like a few more exercises, I think. But I think there is enough of them that if you do, like, you do need to practice by yourself as well. So like watching me is, uh, I think, what you need to do is something like this. So like if you do like spaces, then it becomes code. Okay, so do the exercises as you're preparing for the midterm, but also I think kind of uh, but also just preparing kind of to be able to do project one, doing the pointer exercises would be very useful. So yeah. All right. Okay. I will see everyone on campus at some point. Bye.